Every example you've seen so far moved data from the source to the target without modifying the data, or at least relied on built-in type converters if it did need to modify the data. What happens when the source to the target requires some sort of conversion? For example, maybe you have a color name, but you want to apply that to a property that requires a brush. How can you convert from a text string to a brush during the binding process? The answer is to use a type converter, sometimes called a value converter. You'll see those used interchangeably. The type converter injects itself into the binding process and converts data from the source type to the target type, and perhaps back again. The type converter is just a class that you have to create, which implements the system.windows.data.iValueConverter interface. It has two methods, and that's all: convert and convert back. Convert converts the data from the source to the target. Convert back converts it from the target back to the source. It can be very simple to create a converter in general because all you have to do is move data from one type to another. But it turns out that you can often use the string format property of the binding object instead of using a converter. So even though we haven't really talked about converters yet, before we do, I want to diverge a little bit and talk about the string format property of the binding object. Because if you didn't know about this, you would find yourself writing converters that you don't need to write. Many conversions consist of simply formatting a string, and that's what the string format property is for. You could create a type converter to do that formatting, but it's not necessary. If you want to convert a value into a formatted string, you can often use the string format property of the binding object. It's just another property like element name, path, and mode that lets you specify a string format expression. In all the previous examples, where we had the slider push its value into the text box using binding, in the text box we would see a long string of decimal values, because the value property of the slider carries along with it a large number of decimal places. What if we want to see only 2 decimal places of precision? That's what this example is doing. How is that working? Well, we could have created a type converter that converts from the floating point value to a string with 2 decimal places. And if you're looking at the bottom of the screen, you could probably see right away how we're doing it in this example. We're using the string format property of the binding object, specifying a string containing 0.00, where 0 acts as a placeholder for a numeric digit. So we end up with floating point values that only have 2 decimal places of accuracy. Makes it a lot cleaner here, and it didn't require writing any code to make it happen. As you saw in the example, the simplest format would have the string format equal to some numeric placeholder or some formatting string, as we saw in the example. You can also specify a numeric formatting string as if you were calling the string.format method, something like this. String format equals open close curly brace, then curly brace 0:F1, end curly brace, and that looks confusing. Well, the part to the right is just a string.format specifier. The 0 is a placeholder for one value, and it'll always be 0 because it's only a single value. Colon followed by the formatting string. F1 means floating point value with a single decimal point. Why is that open close curly brace before this? Well, that's used to escape the formatting string, as if it was surrounded with quotes. But since this is all inside quotes as an attribute value, you can't use quotes around that, so they use the open close curly brace to escape it. On the other hand, if you include text, you don't need that escape set of curly braces. In a case like this, where you said string format equals, the value is colon, and then the formatting expression, that would work as it is without that escaping open-close curly braces. Don't look at me, I didn't make this up. In any case, look at the documentation for string.format. the method includes information about formatting many different kinds of things, including numbers and dates and so on, and you'll find that in the .NET Framework documentation. Sometimes string format can't do the job. In that case, you'll need to run code as the data transfers from the source to the target location. To make that happen, you need a type converter. You'll need to determine the source and target data types and write code to explicitly perform the conversion. Perhaps you'll write code to convert back. You'll do that in case you care about two-way data binding. Our sample binds an integer from a combo box to the border thickness property of a border element. What's the problem? Well, the thickness structure has 4 values. So we'll need to create the thickness structure using the single integer value for all of the values in the border thickness. We're going to attempt to bind the selected value property of the combo box to the border thickness of the border. And if you do it, you'll fail. The problem is you have to have a type converter in the middle. I'm only mentioning this because I learned this from experience. I was building a demonstration for one of our other topics, and I attempted to bind the selected value of a combo box to the border thickness of a border, and it kept failing, and I had no idea why. And suddenly I looked up what the border thickness of a border control was and realized that you can't stuff an integer into a border thickness value. They're different data structures altogether. A converter must implement the I-value converter interface. The interface requires the convert and convert back methods. Either one of those can return nothing at all or return a value that performs the conversion for you. Each one of them has 4 parameters. There is the value coming into the method. That's the value you're trying to convert or convert back, and that's an object. You'll have to cast it to the correct type. There's a target type. That's a system.type instance indicating the type of the target. And in case you don't know what that is, you can test it here and make the appropriate behavior because of the system.type of the target type. There's a parameter. You can pass a parameter as part of the binding and pass that information through here to this converter and use that parameter to make decisions as part of your conversion process. There's also culture information, so you know how to format the output from your conversion if you need that information. None of our examples will. Now here's a warning. The converter won't trap exceptions. They're treated as runtime errors that will be bubbled up to the topmost level. You must trap and handle all runtime errors within your converter. You could return dependency property.unsetValue if there is an error. So if it's possible that your converter might trigger an exception, you should catch the exception yourself in the converter and return dependency property.unsetValue. We don't handle this in this simple demo, but it's something that's worth considering for your own examples. Let's try an example that converts from an integer to a thickness structure. Here's our example, binding with converter 2, and in this case, I can choose from this combo box a border thickness, and when I select it, the border thickness matches it. There's no code running to push the value from that combo box into the border's thickness, but there is a converter which allows us to bind from that integer to the border's thickness. Let's look at the code in the markup here. You can see in our border, the border thickness is set to binding, element name equals thickness combo box, path equals selected value. And when I first created this demonstration, that's as far as I went. But the binding never worked. Took me a while to figure out why. It's because we needed the conversion. You can see here that there is a converter attribute, a converter property of the binding object that allows you to specify a converter to use. I've set a static resource equal thickness converter. That means we must have a resource somewhere that defines this behavior. And here we have user_control.resources. Here is the definition of that converter. you can see I have local colon integer to thickness converter x colon key thickness converter. Well, what does that all mean? If I scroll up a little higher in this, I'll find right here a declaration for a local namespace. XML NS colon local says that whenever you see the local prefix on an element, it should be part of this namespace. Binding is the default namespace for this project. That's the name of the project. That's the default namespace. By using the CLR-namespace colon binding, I indicate to the XAML markup that whenever I use the local prefix, I'm referring to something in this project. So here, I say local colon integer to thickness converter. I have a class named integer to thickness converter, we'll see in a moment, and I want to refer to it by name, thickness converter. What this does is allows me to create an instance of this class. I'll refer to it as thickness converter, and down here I have a static resource named thickness converter that acts as our converter. This creates an instance of the class. The class name is integer to thickness converter. This is the name of the instance so we can refer to it. Just to review, of course we need some way to refer to the type converter in the markup. Like any other resource, we can declare the instance in the resources. In this case, it's in the usercontrol.resources section. We need some way to refer to the namespace that contains this class. And to do that, we create within the user control an XML NS colon local equals reference to a specific namespace. CLR-namespace colon allows us to refer to any namespace in the .NET framework, and binding is a CLR namespace that refers to our current project. Then, within usercontrol.resources, we add local colon integer to thickness converter. That's the name of the class we'll look at in just a moment. And then x colon key lets us supply a key, a name that refers to that object. Then, when we need the converter, we create an instance of that class and call it thickness converter and use it as our converter. Well, let's look at the actual code in the converter at this point. Here's the class that I created to perform the conversion. It implements the iValueConverter interface, which is part of the system.windows.data namespace. When I added that implementation, I right-clicked and chose Implement Interface explicitly, and that created these two procedures for me. When it first created them, all each of them did was throw a new exception, and I added this message here. And the fact is that the only reason that exception is there is so that if you try to use this converter without adding code, you'll get a runtime exception that isn't handled anywhere. In this case, if I ever tried to use this converter in a case that did a two-way conversion, I would get, during my testing, an exception that would be thrown, and I could then either add code to fix it or just remove all the code and have the convert back procedure do nothing at all. That's a reasonable alternative as well. In any case, I'm only using this for one-way data conversion from an integer into a thickness structure. It's possible that you might try to use this converter at design time. What I've determined is that Visual Studio often will use the converter at design time, in which case the value is null. So it's simple to just check to see if the value is null or not, and if it isn't null, then do the conversion. If it is null, do nothing at all. So in this case, I make a return value equal to a new thickness structure with a thickness of 0. So if you call this at design time, where the value is null, I'll just return that return value, which is a thickness with 0 on all four sides. If the value isn't null, though, I'll take the value, convert it to an integer, and I probably should check to make sure that what I have is an integer, but since I'm in control here, I know that I'm only calling this in cases where I'm converting from an integer to a thickness, so we're safe. I'll take the value, convert it to an integer, create a new thickness, passing that integer in to the constructor, which places it in all 4 elements of the thickness, and make that be my return value. Therefore, I'm returning back a thickness structure with either 4 zeros or 4 instances of the value that was passed into this converter. The value that's passed into this converter is the path. In our case, it is the selected value of the combo box on our page. This converter makes it just work. We can convert from an integer to a thickness value, and this converter does the work in the middle because the binding object was told to use an instance of this class to perform the conversion. So you've seen how we set up the resource that refers to the thickness converter. You've seen how we created the converter itself. Just a reminder how we use the type converter. To do that, you add a setting in the binding markup extension that looks something like this. We have binding, element name equals thickness combo box, that's where we're getting the value from, path equals selected value, that's the property of the combo box we're retrieving from, and then converter equals, and we specify a static resource in curly braces like we always do for static resources. And we have a static resource named thickness converter. That's the name we gave to the converter in the resource. Notice that we end with 2 curly braces, which looks weird because we have one curly brace to end the converter and the other curly brace to end the binding. If that bothers you, rearrange the order of the attributes so that you don't end with converter. It doesn't bother me. I'm sort of used to it by now. Now, Visual Studio does give you a tool to help you hook up this converter so you don't have to type it yourself. You might like this better than doing the work by hand. So let's go back to Visual Studio and see how you can take advantage of this tool to hook up a converter using Visual Studio. I've loaded the sample page binding with Converter 2 and selected the border and the border thickness property in the Properties window to prove a point. I can do all of this work interactively using Visual Studio's tools. To do that, let me reset this value to remove the existing converter, and also I'll remove the resource. So we're starting from scratch here. How do we make this happen? Well, let's set the property of the border that I need to set. Here's the stack panel. That's not it. Here's our border. There's our border thickness property. I'll click on it and choose Apply Data Binding. We get this box which lets us select the source, the element name, and all those things. So I'm going to specify an element name. We really only have one place to get the information from, thickness combo box. Down here in the path pane, let's choose the path we'd like to use, which is selected value. We also need to specify a converter. So I go to the Converter tab, and I can hook up a binding to integer to thickness converter. I need to create a new resource to attach it to, and I'll name it thickness converter. At this point, I could supply a parameter. Remember, there's that parameter in the converter, which allows you to pass information from the XAML to the converter. I have no reason to use it at this point, but I could supply a value here and retrieve that value on the other side. There's also an Options tab where I can specify things like a string format. Look at all these built-in formats. Isn't that nice? Or a mode, which could be 2-way, 1-way, whatever the mode is supposed to be, and other options as well. Clearly, there are many more options. We've set up the binding. Come back here, and now you can see exactly the same text we had before. Border thickness equals binding, element name equals, path equals, converter equals. And up here we have the resource which defines that converter for us. So if you're a little squeamish about typing this stuff by hand, you see you can use the interactive tools provided by Visual Studio to do the work for you in hooking up this binding.